Okay, 10.1, again, we are exploring conic sections. So in class, if you were here today, you saw us graphing an example of a circle. We graphed the equation x squared plus y squared equals 25. Example 2, let's graph the equation x squared plus 4y squared equals 36. And if you look at this equation, this looks a little different from what we did in class. In class, our y didn't have a coefficient. We didn't have this 4 in front. So let's see what happens. Let's see what kind of shape we end up with here. So to graph our conic sections, right now I don't know what this looks like. So let's try to come up with some values that we could use. If I try to think of some values here, I'm just going to look at the x squared for a second. X squared could equal 36 if x is 6. So 6, 0 gives me an ordered pair. Okay, because 6 squared is 36. If you plug 0 in here, this whole term is 0. So 36 plus 0 is 36. We can also get 36 at this x squared term if we plugged in negative 6 for x. So I'll make this plus or minus 6. Okay, because again, negative 6 squared is 36 plus 0. We get 36 again. Okay, let's see what else we could get. If I cover up this term, we could get x squared to equal 36. Let's see if we could get 4y squared to equal 36. So 4y squared equals 36. Let's see, 4y squared equals 36. Let's do some work here. Divide both sides by 4. Y squared is 9. So y could equal plus or minus 3 if x is 0. That works. Let's use that. And just to give us a little better of an idea of what this looks like, I'm going to plug in one more value. And there aren't any other easy ordered pairs that we can come up with that are nice whole numbers. So let's just try plugging in a value for x. Let's try plugging in, I don't know, let's plug in 3 for x. Okay. So if x is either positive or negative 3, this is what happens. Plug 3 in here, we get 9 plus 4y squared equals 36. To solve for y to get y by itself, just like any normal equation, we would subtract 9 from both sides. And that gives us 27 here. Now normally we keep our answer exact, but since I really am using this for graphing purposes, we can figure out what this is about as a decimal. So I would divide both sides by 4 and then square root. So the square root of 27 over 4 is about 2.6. Okay, let's use these points now. We have a good chunk of ordered pairs that we can use to graph. So let's use these ordered pairs. Plot and see what we end up with. Put my little graph over here. Plus or minus 6, 0 means I can have the point 6, 0 or negative 6, 0. 0, 3 or 0, negative 3. And then we could have plus or minus 3, plus or minus 2.6. I could have 3, 2.6, 3, negative 2.6, or negative 3, 2.6, negative 3, negative 2.6. And hopefully you can kind of see if we connect these dots here, the conic section that I'm ending up with is this oval shape, which is the ellipse. Now, a couple other things we can think about with our conic sections, and really any graph in general, is what kinds of lines of symmetry this ellipse has. So lines of symmetry, again, where is our graph symmetric? Where is our ellipse symmetric? If I folded my paper, where is it going to be the same on both sides? And hopefully you can kind of see, if you fold your paper on the y-axis here, our graph is the same on both sides. Same if we fold our graph over the x-axis, fold our paper here. It's the same on the top and the bottom. So our lines of symmetry, the y-axis is the line x equals 0, and the x-axis is our line y equals 0. And then domain and range we can figure out just like, again, any other graph, any other equation. Our domain, looking at our x values again, the smallest x value we have is -6, the largest is +6. So that tells us our domain, x has to be between -6 and 6. And then our range, same idea but looking at our y values. Lowest y value we have is -3, the highest is +3. Y has to be between -3 and 3. Okay, so again, our equation here, where we have x squared plus 4y squared equals 36, this gives us an ellipse. If you notice, we have our two terms added together here, but we have the number in front of just one of the variables.